All right, how to use the beads to really get the true milliliters of oxygen that the seeds took in, so we can figure out the rate at which that happens. So let's just go, I'm going to go through this as an example. This example lab was different than ours. They did it at 2 different temperatures, and they did it for time every 5 minutes for 20 minutes. Different groups did different things. So this is the part of the data table. I'm just going to cross this out here. You don't have to cross yours out. So we only have one temperature, it was room temperature, and we have our time. And so let's say we did this, and this part here says beads alone. And so you guys got your raw data. So let's say in the first time 0, the beads read at 0.12, and let's say the beads did move. Remember, the beads, if any movement occurs in the beads, it wasn't due to cellular respiration. What caused the beads to move, if they did at all? Ellie?
Change in air pressure.
Change in air pressure, absolutely. And so it could be a change in temperature as well. Our water baths, though, were hopefully pretty stable. But let's say it did move. And so after 5 minutes, let's say our reading was 0.10. So in looking at then this, if this was the stopper, here's your pipette, and this is your beads down here. What that meant is that here's 0.12, that it went in to 0.10. So the water went in. That's how we read it. And so then the difference, if you read down here, the little asterisk, the difference is the initial reading at time 0 minus the reading at time x. So therefore, I'm going to take the initial minus at 5 minutes, and so my difference here is 0.02. So then it looks, if we look over here, it looks like the beads took in 0.02 milliliters of oxygen, but they didn't, right? We know that they didn't do that. So what's causing that? It could be a change in air pressure. That, imagine I'm putting more pressure on the water. That's going to cause the water to move in, because the air pressure will then be greater than the pressure in the water here will be greater than the air pressure inside the respirometer, and it'll move in. And so therefore, when we look at this and do this for the beads, and we look at for the time period how the beads changed, we have to correct that with each of our seeds. So let's say this is germinating peas and dried peas. We use different seeds. So let's say I use peas and mung beans. All right, so here are my 2 seeds. So let's say my reading for my peas at time 0 was 0.23, and let's say after 5 minutes it was 0.18. So then I take my difference here. My difference is 0.05. So again, looking in a picture here to make sure that we all understand what's going on here. So in our peas, it started out at 0.23 and went into 0.18. So therefore, it looks like my peas took in 0.05 milliliters of oxygen. But if we look here, my beans, according to this, took in 0.02 milliliters, but they didn't really take it in, and that's because of the change in air pressure. So therefore, when I look at what happened to my peas, I can't say that my peas took in 0.05 milliliters of oxygen, because my beads took in some. So therefore, the beads took in 0.02, so out of this 0.05, 0.02 of that is due to the change in air pressure. So therefore, my peas really only took in 0.03 milliliters of oxygen, because the 0.02 moving in was due to that air pressure.
So, okay, so for my beads, like for the time 15 and 20, it grew from 4.6 to, well, it grew from 4.6 to 4.7. So the change, like the difference was 0.1. But then once I go to, like it grew,
It didn't go down. So you're
down.
saying here that it grew here. So let's look at how that would play out. So let's say instead of here let's say we have the 0.12, and then you're saying it went 0.13. Like it went up.
Yeah.
Okay. I mean, it's not going to be your exact data, but so then my difference then is still initial minus. So in this case here, instead of it going in, it went up to 0.13, so it went in this way here. All right, which means then we had a decrease in air pressure. Does that make sense?
Yeah.
Okay. So then how that's going to relate, so your difference here, take initial minus the time, so 0.12 minus 0.13, so if this is my data, I would have a negative 0.01.
So okay. So, and then it stayed at 0.13, so then it would just be a zero change the next step down.
All right, well, hold on. All right, here. So this would be a negative number here. All right, and then, so then let's look at the second data. So let me show you the data point. You're always going to do the difference, always goes back to your initial time. So let's say my next one was 0.09. So I go back to my initial. So for you, so here it would be 0.03 because it's always going back to your zero at time zero minus at whatever time period that is. And so here it will be 0.03. Let's say my P's took in, now it's at 0.014. So then I go back to my initial 0.23 minus 0.14 is 0.09. So then my corrected difference would be 0.09 minus the 0.03. So I have 0.06 here. And this one would be, I just write this down, 0.03. Is that following me? So yours going back, and I can, did anybody else, the beads go out like that? Yeah, okay. Okay, so then what you're gonna do is then you would have a negative number here. So if you had a negative 0.01, then you take the difference minus the negative number, so you're really adding it. Does that make sense?
For the corrected difference?
Yes.
So for the difference, you just record like the actual, okay, I see.
Because if it actually went out, then why you'd have to add that to it is like for the P's, like you'd add it to it because the beads went out instead of changing or staying the same. Really, then the P's took in an extra whatever that is because it went out instead of going in. It should have gone in.
Okay.
That amount. Okay. So if you have any, so this is what you're doing. So you're figuring out the corrected difference. And so this is the first thing I want you to do today is with your data. So you should have your raw data from your readings. What I'd like you to do is you can either use this chart and change or make a new chart on a separate sheet of paper. But I want you to figure out the difference and then the corrected difference because it's really these two columns here, the corrected difference of your two seeds, that's the important data for this lab. Okay, so that's what we really want to do. So that's what I'd like you to do right now for your data is to get the corrected difference. Okay, so do that right now. And then I'm going to kind of walk around it. If you have any questions, let me know. When you get done with the corrected difference, different groups will get done at different times. When you get done with it, right here, you're going to call me over because I want to look at your data. I want to see if your data is good. Alright, and so on. And just double check that you did the corrected difference correctly. Alright, because some people, somebody in other hours,
Monday is fine.
Yeah, we should have a data like that.
like the initial, see how the initial was higher than the initial
I know, I was like, okay.
Low. Yeah, but it looks like it's still going down. Let me get one. Now I'm.
What do we pull for zero?
You take the difference in like the Germany and we're gonna do this difference minus that.
I was thinking
Your record, then you get the correct.
we just put keys there, right?
Yeah.
Well, I can't, well,
Okay, this makes sense.
yeah, and what's, but see, what's really important is the marketing. Like this data can always do a little bit of idea. The number we're gonna have, so that's good.
We'll see how much more difference the other ones
On the
are.
first step, then they stabilize.
Oh,
Yeah.
After 5 minutes, they dropped a little bit, and then they went up at the end in the last step.
So yeah, so go ahead and do this with the correct comment.
Well, we were really rushed because we were running really late, so I was over there.
2 seconds. 5 numbers.
Okay, so.
Oh, it's from the.
I did not go back to the original. So it's cumulative.
Just put it up a little bit more.
So
Wait, I'll look up here and see if there's more left.
But then also saying the difference for the grades, you have to go back to like this. So both of, instead of your inclusion, I saw that like you're writing a different number of these two, but you don't have the difference. So these two are.
Just like every 3 weeks, we have like, so the initial water level is the reading at time and reading without.
I just said like.
Like for. Yeah, we can't do that.
Oh, and the little like.
Oh.
I just messed up this whole short. That sounded really bad. It's true. I love a piece of paper. Yeah. I'm so nervous for the pre-calc test. I feel like I'm gonna do so much. Yes, I'm gonna retake it too. I've all my homework done, so I can What?
So when you make the graph you're graphing just the data of interest, which is the corrected difference, because this is the milliliters of oxygen that your P's are taking in, and it's a cumulative milliliters of oxygen. So therefore, as time goes on, if they're doing cellular respiration, the corrected difference should go up. and so these are the two columns that we're gonna graph. So if we do a graph of our data here, what do you think goes on the x-axis? What do you think goes on the x-axis? Time is gonna go on the x-axis. And everybody measured time in what units? Minutes, right? How often did it vary from group to group? But everybody did time in minutes. Now, last hour we had trouble figuring out what would go on the y-axis. What would go on the y-axis? What do we actually? It's the corrected difference, but we're not going to write corrected difference. What is the corrected difference? They're calling it corrected difference here, but what is it actually telling us about our seeds? The milliliters of oxygen that they took in to do cellular respiration. So I'm going to write here the milliliters of oxygen consumed by the peas. And in that label, I've already put my units. It's milliliters. All right? So this is the oxygen consumed. And so then what you can do is you can make two lines, and I want you to do best fit lines for your two different kinds of peas that you use. We don't need to graph the beads because we're studying cellular respiration. The beads is not doing cellular respiration, you do not graph the beads. All right, so you're just graphing two lines for your two seeds. And then, remember our question had to do with which one has a faster metabolic rate, a higher metabolic rate. Well, in order to figure that out, what about the line am I concerned about? How do I use the line in the graph to figure out rate of cellular respiration for my seeds? Slope. So thank you. So slope is, so we want to figure out how many milliliters of oxygen consumed over time. So we're going to see milliliters of oxygen consumed per minute because that was our time. And so then when you make your best fit line, you can take 2 points on each line to figure out the slope and therefore figure out the rate for your two seeds. Does that make sense? And see if which one has the faster or a higher rate of respiration. Got it? Alright, so finish up whatever you were doing there, and that's yeah, and although we're not doing it, yeah. So that's the last thing. Okay. Okay.
Thank you.
Yeah, no problem.
Is there a marker, like two markers for, yeah.
Something 40 long. You do a horizontally, 40 on the bottom.
Why?
So, divided by 20.
So if we take this back to
What?